Hello! We are now going to start learning about quantifiers and variables, which is where the real sort of logical action is in predicate logic. So first of all, let's remember, because we very may have easily forgotten because it went by quickly, what these new symbols are called. These are the new logical symbols. These are like the arrow, the negation, and, or, if and only if. These are the logical words. So we've got the upside down A. They're both called quantifiers because they quantify, say how many things there are of a certain kind. So they're basically quantity words. So quantify how many. So the upside down A is called the universal quantifier, and roughly it means every or all. And every is in a way a better translation, but all has the A in it, which is where the upside down A in the universal quantifier comes from. And then the backwards E is called the existential quantifier. The best word for it is some, but it also can mean exists, like there exists at least one. And so that's where the backward E comes from. So upside down A, universal, all or every, backwards E, existential, some, or exists. Now we're going to learn about how they work. The way they work is in interaction with variables. And so actually in this video, I'm going to talk about variables a little bit, and then we'll, having talked about variables, go back to quantifiers. So logical sentences with variables are kind of like English sentences with pronouns. So let's just look at some examples. So we could have the sentence, x is less than 7. And we say, well, is that true or false? Well, by itself, it's not. It's only true or false if we talk about what particular value we're using x to talk about. So that comes out true if x is 5. It comes out false if x is 8, and so on. So what do we use x to talk about? Once we've picked, then we can say whether or not the sentence is true or false. X by itself doesn't refer to anything. We have to assign a value to it. Or in English, we could have the sentence, it is a chair. So is that true or false? Well, it depends what we're using it to talk about. If we use it to refer to, say, this thing, then it comes out true. And if we use it to refer to this thing, then it comes out false. Okay? Or if we said X is a chair and purple, well, if we used X to talk about this, it still wouldn't work because this is now not purple, even though it's a chair. The only way to make X is a chair and purple come out true is if we let X refer to a purple chair. Okay, so what about formulas in the logical language? Well, let's take gx and let's say, just stipulate that g is going to mean is green. So then we can ask, when x refers to an object, is gx true? In other words, is gx true of that object? We take the variable. It's a variable because it can refer to what it refers to varies, right? It changes. First we use x to refer to this, then to this, and so on. So we can ask, once we've decided what x refers to, then we can ask, is gx true? The whole thing. We ask, is gx true of that object? So, is gx true when x refers to me? No, because I'm not green. How about you? Well, I assume not, because I assume that you're not green. I don't know, maybe you are, but I doubt it. This, on the other hand, if x refers to this is kind of green, and so it's at least somewhat true, maybe totally true. If x refers to a plant, the right kind of plant, then it's probably true. Most plants being green depends upon which one we pick. Some plants aren't green. The moon? No, the moon is not green. What about fx and gx? Well, let's say again g means g is green, but then f is going to mean f is a frog. Okay, so true or false when x refers to me? I'm not a frog. I'm not green, so both pieces are false, so the conjunction is false. You, well, I don't know whether or not you're green, but when we use x to talk about you, fx comes out false because you're not a frog, unless some strange biological shift in evolution has happened and now they're intelligent frogs, but no, you're not a frog, so fx is false of you, and so the conjunction is false. When we use fx and gx, if we use x to refer to this, fx and gx comes out false because while it's green, it's not a frog, and so fx is false, and so the left conjunct is false, and so the whole thing is false. It's false when we refer to the moon. On the other hand, when we use x to talk about that, well, that would be a frog, and it is green, and so fx and gx would come out true, right? Fx and gx, which things is it true of when x refers to them? Green frogs and nothing else. Okay. More complicated, fx then gx. Now this is tricky. So let's think about what happens when x refers to me. Is this true or is this false? Pause the video and think about it. obviously there's something tricky going on if I told you to pause the video. When x refers to me, it's true. Why is it true? Well, I'm not gx, so I make the consequent false. I'm also not fx, so I make the antecedent false. Right? So when we're using x to talk about me, then both parts of the conditional are false. Yeah? So we have if false, then false. And when we have a conditional that's if false, then false, that conditional is true. And so this conditional is true when we're using x to talk about me. That's the funny way the arrow works, remember, right? It's the only time the arrow comes out false is when the antecedent is true and the consequent is false. Otherwise, the arrow sentence is true. So that arrow sentence, when we use x to talk about me, the whole thing is true because both pieces, fx and gx, are false. And the same thing is true when we're talking about you. You're not a frog, so you make the antecedent false, and therefore you make the conditional true. How about this? Same thing. In this case, the antecedent is false and the consequent is true, but again, that's a true conditional. When we're using, let's say we use x to talk about the moon, then again the conditional is true because the antecedent is false, and so the conditional is true. When we use x to talk about this little animal or Pokemon, then both pieces come out. Then both pieces are true. It's green and it's a frog, at least partially frog and partially green. Let's say they're both true, and therefore the whole conditional is true. So how do we get fx and gx to be false? If we're going to talk about something, we're going to say this is the thing where when we use x to talk about it, fx and gx comes out false. What is it? It's these things. These are called arrow or poison arrow frogs. They're very poisonous. Don't ever touch one. Certainly don't eat one. Are they frogs? Yes, so the antecedent is true. Are they green? No, one's blue and black and the other is yellow and black. So in both cases, the consequent is false. And there we have the conditional coming out false. So if fx and gx comes out false, why? Antecedent is true, they're frogs. Consequent is false because they're not green. So we have true then false when we talk about either of those, and then we get a false condition. So hopefully, I hope that these examples we've worked through have helped you to understand how variables work, at least variables when there are no quantifiers around, right? Notice in all these formulas, there are no quantifiers. So when there are no quantifiers, we can use x to talk about this thing or that thing or the other thing. Which one? We just specify. We say I'm going to use x to talk about this, and then we can ask whether or not it's true or false. And we've seen some examples of how that works. So in our next video, we're going to start talking about our actual quantifiers. Hooray!